Alright guys, welcome back. We're going to be solving another question from the chapter 4 of engineering mechanics by Meriam, and in this one, we have a 20-pound gripping force that is applying on the handles of these two, and we need to determine the normal force N that is exerted on the round stock by each jaw. So we're going to be having a normal force on this jaw. And in the second part of the question, we are also asked to determine the magnitude of the force supported by pin at point O. So as always, we're going to start with the free body diagram, and I'm going to draw the free body diagram. We can pick either the upper handle or the lower one. So I'm just going to take this one, and we're going to have the 20-pound force that is applying in there. We have a pin at point O, which means we have both horizontal and vertical component. We're going to call it OX, OY. I'm just going to consider this direction for now, which is positive if we just call our X and Y in here. And also we're going to have a normal force N that is applied from the stock to the jaw. So let's just show it like that, because this will be the normal direction. So that would be our N. And that's pretty much everything for this free body diagram. We have three unknowns, OX, OY, and N. And obviously we are in equilibrium, which means we have up to three equations. So we should be able to find all of these. Just a reminder that our equilibrium equations are sum of all forces in X equals 0, same for the 1. And we're going to have one moment equation here to find all the unknowns. So it makes sense to start with the moment equation since we have most unknowns at point O. If we just find the moment about point O counterclockwise positive, as always, we're going to get rid of OX, OY, and we should be able to find the N. As for the first unknown, and we're going to use the 2D shortcut, if we look at the 20 pounds force, we'll see that it's going to make a clockwise moment. So it's going to be minus 20 times the distance, and we are interested in vertical distance from O to the line of action of this. And if we look at it, we'll see that we have 16 inches. So 20 times 16, that would be our moment from the force that we have. And also we have the moment of N. If we look at this one, we'll see that the N is actually counterclockwise, so it will be positive N. And again, we are interested in from the distance, or I should say vertical distance from O to the line of action of N, which if we look at it, we'll see will be 4 inches, and that would be equal to 0. And if we just calculate this, we can see that our N would be 80 pounds. And that would be the first part of the question. The rest of this is pretty easy. We just have to do sum of all forces in X and Y equals 0. So for X, we're going to have OX. We have the X component of N, which we can resolve it in these two. So if that angle is 70 degrees, that means this angle here is also 70 degrees. And if we want to find this side, that would be the N, which was 80 sine of 70 degrees, since that would be the opposite side, and the X component would be 80, oh sorry, the Y component would be 80 cosine of 70 degrees. So we're all set. We have plus 80 sine of 70 degrees equals 0. We can see that our OX will be negative, which shows that the correct direction for OX is actually to the left. So negative, let's just calculate this. 80 sine of 70, that's going to give us 75.80 newtons. Again, the negative sign shows that it's to the left. And one more equation, sum of all forces in Y equals 0. We're going to have OY. We're going to have the 20 pounds downward, so minus 20. And we have OY also downward, so that one's negative 2, minus 80 cosine of 70 equals 0. So OY would be basically 20 plus. So this time, instead of, so 80 cosine of 70, and we just have to add 20 to this, so it's going to be 47.5 36 newtons. This one's positive, so it shows that the direction is actually upward. And one more step here is just the magnitude of the force at O, which would be the square root of OX squared plus OY squared. And that's going to be square root of 75.18 squared plus 47.36 squared. And that's going to give us 88.85 newtons. And the magnitude of the force at point O. Sorry, all the units in here are in pounds. I don't know why I put newtons. So if we get back to the question, we'll see that everything is in pounds. So I don't know why I started changing the units in here. That would be pound. And yeah, so hope everything was clear. Let me know if you guys have any questions. And you guys take care. I'll see you in the next video. Have a good one.